want to put out those two of the small of the structures on the side. Can you guys see my mouse move on there?
Yeah. Yeah.
Oh, yes. Okay. So can some of the health providers or you are teaching medical science class, can you tell me what it is, how these two of the small structures?
That's a good valve.
Valves, very good. So I'm not questioning you guys. Okay, I'm sorry, I'm not quizzing you guys either. But this one, I do want to show the students on these valves, basically stenosis and the regurgitation. Not, if you're not in the science class, I'm not going to quiz you. Okay, so these are two of the pathological conditions. One is stenosis, one is the regurgitation. That's what I want to see. And I present these two of the models to the students with this big of the normal heart. We can see the valves right here too. Okay, I'm not going to lecture at this point. I want students to see what would happen and I let them analyze a case scenario. If the patient have stenosis, how they affect the cardiac output, how affect the EF. Okay, stenosis have to be smaller than what of the criteria, like less than 1 centimeter or something like that. So what significant decrease EF? So that those things I use for the class. Okay, so this is one of the female reproductive model. Actually, Mark had a
Yeah,
half.
go ahead and pass it around here.
Yes, Mark have half and I have half. Why is that? Because we print out as a white model. So I use the markers to try to label different structures right here. So Mark is more.
Wait, Sophie, I'm going to stop you for just a second. I'm going to explain something
Sure.
they're seeing, so I can only have to do it once. There's some fuzzy
Okay.
material in here. This is from what's
Mhm.
called the support. When you print things that lean on each other or might fall over, it does a support. So this fuzzy stuff needs to just be cleaned out a little bit more. It's not actually fuzzy there. It just needs, that's from the support side of the stuff. So there's support material that happens as well. Okay, sir, Sophie, go ahead. Sorry.
No problem. Anyway, so that is great. And you know that take out that support films is very difficult. So I assign it to my students to do it. So they said it's very therapeutic. You can make them skill a lot of time when they are studying. So you can pick up all those things. But anyway, so I found actually when we print out on the white based, you label these different colors, is ideal. So it's pretty significantly you can because I know what it is, so I just labeled on the different colors at this point. So I could assign to students like the lab practical test, let you label it. What do you think? Right? You label this structure as red, label the ovary as green. You label it. So everybody can get one. So if we have enough of the material, we just can assign to the lab practical. Let students label instead of us to label it. Does that make sense?
There, the other piece is, just so people know, that total project with the 2 parts actually took 72 hours to print.
Yes.
So it's not something that happens, and that's partially because of the supports. And you can actually see the more squared off pieces over on the left-hand side. That's part of the supports that were done, and so you break those out. It just helps support some of those pieces that are up above that would normally, because it's hot plastic, fall down.
So doing one for each student would be really laborious.
Yes, we would not want to, yeah. Laborious, at some point there will be a charge.
Yes.
Sophie did a really nice job for us, so I want to say thank you, Sophie, for the filament. Part of her grant that she did included some dollars for filament. So we've got about $200 worth of filament from Sophie. So thank you very much, Sophie.
If you don't mind me asking,
You're welcome.
how much did that bottle cost?
Yeah.
This, I think, was probably between $10 and $15.
Okay.
And printing for 36 hours, I wanted to see it more often, so I stopped in throughout that to see. I could have just as easily, well, the second half I actually did. They said print it. It came back 36 hours later after the weekend and it was done. So it's not like you have to sit there and do something physically with it for 36 hours. Hit print and go away and come back when it's done. Okay, Sophie.
Okay, Mark, thank you for the price wise. For the individual students, maybe not ideal at this point. I do believe the cost could be on the size of the model as well. If we really use for the students, I could use the next slides. I just talking about that is very small pieces we print out. Could be a little bit cheaper, so I can show you next slides. Did you see this one? I'm not going to quizzing anybody of it. This one is bifurcations. Okay, so for the carotid arteries. And anyway, so between the common carotid arteries and the internal and external carotid artery. And anyway, so I print out because the students require, they want to see it. I will show you the students' feedback. I did have reflect journal after they did a 3D lab tutors and doing some of the presentation on that earlier valves, stenosis, and regurgitation. So they said they want to show this model. So this one I print out as red, but I use marker white. Try to label it right here because this right here is very important. We have the carotid body, basically our peripheral chemoreceptors located here. So, but it's not really great when I was using white color on this red material. It's not very significant. So we are still in the experimental stage. So I want to see what kind of the material I can print and what kind of color I can add on. So I do think, in the future, we could buy a colored 3D. That would be more, yes, ideal, but more costly too. But this is the one I definitely absolutely using our pathology class and most of the AP class as well. So this is students could see I labeled it right here as white. Okay, so we identify these specific structures. Okay, so if I want to test the student like this smaller structure, their printing time maybe is a little bit shorter, right, Mark? Like those smaller pieces. Yes.
Correct.
Maybe not as costly as the big piece of the model. So this actually is the video, and Mark sent to me, showed how 3D working. I think currently that 3D is working right now. So that is how that happened, right?
Yeah, so this is certainly a time lapse because you're seeing 36 hours of printing happening in a matter of about a minute and a half, probably. So
Yes.
this actually takes film and takes time-lapse photography as it's printing your device.
Oh, it does that?
It does that.
Oh.
Yeah, so it will actually create that. And so you can see the support structures going in place on that one now. But it actually takes a picture every second or so and then stitches that together.
What was read to make it create that? Like what is plugged into it to make it print such a structure?
What was plugged into it?
I mean, I.
What's directions
What
like?
did you say?
Okay, so there's a file that people create. So Sophie, I'm gonna take a second here to just jump in on where we're
Yes.
probably going with this. It's called an STL file. So if you've ever seen somebody draw CAD kind of thing, like an architecture or a house or something like that, if they draw it in 3D, that can be done into an STL or a 3MF file. That's the type of file that's there. That's more for doing, and well, I shouldn't say STL, but most people then are going to picture something like this. It's more structural, more kind of formed instead of organic. But what we're working on right now is women's and children's both have sonography devices that will create an STL file. So you can take your sonography tools and actually go through and grab the sonography images and have it create an STL file from that for something more organic. So one of the projects they're actually talking to us about is mothers that lose babies. They want to do a sonography of the baby so they have a picture of the baby's face, foot, hand, whatever, and then 3D print that and give it to the mother. So they're talking to us about possibly having a printing capability for them to be able to do that, but they would then be able to scan it, send it to an STL file. I don't know what the cleanup process is. I'm expecting that cleanup process is probably pretty significant. but then being able to take that STL file. So lots of pieces. It's getting really interesting. Andrew downstairs and I were talking earlier today about how it's really becoming more consumer centric. So I can actually get a sonography device for under $500 that plugs into my phone. And I can do sonography on my phone. And we're talking about, wouldn't that be cool if you could then send that file to an STL file and print your own kinds of things. So some really interesting things that can start to happen with this whole printing capability. All right, Sony, or Sony. So Sonia and Sophie become Sony.
That's great. Yeah, anyway.
Yep.
Yeah, this one just showed part of my students' reflective journals on the 3D models. I use that two small pieces and the stenosis and the regurgitation, that is their reflex on it. Okay, so those I have this is sonography students, so they are actually analyzed really in details. So I hope our nursing students can do the same thing as well. You know, I could give them as a case study, but they did very well on this analysis. Okay, so this is just one example of how they use the stimulations, visual stimulation directly and reflect on what they learned. Okay, so however, this is another one. I just said that I pick up a couple of those. I have that time I have 15 students, I do believe. So anyway, so they are doing pretty good on this analysis. Okay, so I just show they are very details and they give the numbers how much they could decrease the EF. Okay, so this great. I show this data. But anyway, so the future students' perspectives. So that I also asked on their refractive journal. I said, what do you want to see in the future from the 3D printing techniques? What do you want to do? So this is one of the students said, you know, of course, the OB. So she wants the female reproductive system. That's the reason why I did print out the female reproductive system for future our, you know, the sonography students use. I want to use more of, this is one of the normal I print out, but in the future, I'm going to print out abnormal structures, such as the uterus change the position, become anterior, posterior, from anterior to the posterior, all those positioning change, or they can see all those, you know, obstructions on the fallopian tubes, all those kind of things, or the fibroids, all those things. I could show the students how this happened, especially those ultrasound via vagina, all those kind of things. I would like to print out more of the models according to students' request. Yeah. So there's another student who said she want to see the blood circulation through the placenta and the fetal heart. So this is one used for the, I think it's pretty advanced because our children's hospital, we do have a lot of like a VSD, ASD, those most common of the patient. We do have a tetralogy of fellow, those kind of the patient in the children's hospital. I do want to print out more details of the fetal heart because even though in our AP lab, we do not teach too much of the developmental stage or embryology, yeah, embryonic stage development. We don't have too much model on there, so I'm going to print out that. Okay, so this is the one of the fetal circulation I want to print out. So the future plans, I just said, first things is help the students for any of anatomical and anatomical structures understanding. Okay. However, I do want to mention a little bit more on this 3D printing medical records. So this one, I do believe we can collaborate with our health system because I do believe children's hospital, they have medical students, they did create those 3D printing models for the patient education because we can create that specific models according to that specific patient's structural change For two reasons. It's easier for us to have the future get out the treating plans. Okay, so we can see visually. Okay, so what kind of surgical plan for the surgeon to plan for future. Also for the patient education, we will tell them this risk. You have bigger of the arteries, such as you have a abdominal aorta just behind where you have a mass grow on here, right on the celiac trunk, so they will compress the blood supply to something. Okay, I just briefly talking about that. So this is the one of the advanced techniques already used in some of our local hospital. Never mind, there's a lot of use for those teaching hospital nationwide. So this is the one we should collaborate with our hospital settings. So another one is our knowledge table already have a lot of imagings. So my next step in the next couple months, I'm going to pull some of the imagings from the knowledge table because they have a different file. I have converted them once at least, then print out real pictures. So the student real 3D objects. So the students can use the 3D objects and look at the knowledge table, that specific case. Like they can doing comparisons between those two. Yeah. So I also work at the microbiology lab. So I found there have the fewer of the models. So I would like create some of the other models we cannot see by naked eyes. So such as virus, COVID virus, that's the one we don't have, and some of other microorganisms model. Okay, so next one is the equipment and the device. I do believe that this one is, I mentioned earlier, could use for the occupational and the physical therapy program. Okay, so most very important part is collaborations. So as a colleague, I do believe collaboration, you can give me the more idea to light it up. We can work together and make this 3D printers more useful our education, not only for education, but for future students' perspectives, like the care for the patients. So that is all my presentation, actually very short one. So I really appreciate you guys coming. Any questions?
So how often do you bring these models to class? Is this like you get a chance to take this a lot, or is this something that you are still maybe once or twice a semester?
Depends on what thing assignment is assigned me to teach. So anyway, so usually pharmacology class, I don't use any of the 3D model. Okay, so this is the first round one. My grant was approved was end of December. So I did bring to the sonography class, that pathology and pharmacology. That is that class I did. And however, I do not teach any pathology on campus this semester, so I don't have a chance to present to the student. I don't teach any pharmacology. I don't have models. But the next one in the fall, I do have pathology and the AP. I'm going to bring more to the class. Depends on my workload, class load.
A question for either Sophie or Mark. So I'm looking at this model of the women's reproductive system, and I think, when I go to my OBGYN, there's this big model of a women's reproductive system. So what's the advantage to printing these versus buying models that you see in doctors' offices?
Okay, I can answer that questions. Okay, so those are, if you hung in there, like some of the office did have 3D model, almost not only the picture. If the picture only 2D, of course, do not help the patients too much. 3D model, you can print exactly size according to that patient's, such as if the patient have enlarged uterus, we can print out that one according to that patient's size. So specifically, this one is more like, if it's normal structures, we do have the normal structures in our AP lab. I think this one we can use is more pathology change. Like we can print out even the ectopic pregnancy. So
Yeah, that
to
makes
educate
sense.
the patient.
The other piece is the library that you can create, because I've got faculty members who come in and want specific things. So Shannon Struby put together a spinal puzzle. So she has all the vertebrae, but the students have to actually put them in order as a puzzle. So what clued you into why this one went where it did, and things like that. We've got a brachial or a bronchial system put together. So you can really start to build a lot of 3D models for relatively cheap, which is kind of handy. And like you said, kind of those atypical kinds of things. So there's actually a surgeon that's I got this file from. He's got the model of a valve, but we've got material that you can print now that's squishy like the valves. And he actually uses this to practice his suturing techniques and practice it and try it and be able to actually do the stitches and sutures into the material. So not only is it, and that then is a one-time deal. It gets done, now that one goes, but for $5 we can print another one or you can try it again.
Yeah, somewhat related to that, Sophie, I was gonna ask you about your heart model. When you created the valves, did you just do the AV valves also semi-lunar? And then is it also a puzzle piece to like interchange normal, abnormal, so that the students then can possibly like be quizzed on it? I'm just curious for my own use in classes.
Yes, we can create a model, actually put that model in the like a puzzle. So cordon tendon attached to which of the valves, which is have the 2 cuspid, which one have 3 cuspid. Yes, we can print out separately and let the students put together as a lab practical. We only need 1 model, right? That is cheap.
Okay.
This was option, printed that.
I
So,
think Shanna
Mark-
wanna, yes.
Yeah, can I add just
Yeah.
one, just one thing? So we did do a model of the bronchioles. Mark was nice enough to make me actually a couple of them for when we covered pulmonary here a couple weeks ago. And the students have to learn postural drainage, and using those bronchioles to provide like a 3D image of this is why you position the patient this way versus this way in order to have a successful drainage. The students this year with that visual picked it up a lot quicker than previously.
Sure.
So,
Yeah.
Thank you, Shanna. More
Sophie,
questions?
Can I ask, how hard is it to get this STL file if you conceive of an idea for something you want to get printed? It's not just like typing a Word document, I take it.
Actually, it depends, and there are huge libraries out there of STL files already created. So you can go download, there are files that are absolutely free, so there's thousands of free files that you can download for just about anything. But there are files that cost hundreds of dollars even just to get the file, depending on what it is you're looking for. So they get very detailed and very complex, and so there's that. But we also have the ability to build files here through the sonography devices, and I'll show a tool that Melissa's looking at for actually designing braces custom fit for patients.
NIH has a huge repository of files. Huge.
And those are
Free access.
Yeah, so there's
very cool.
lots of ways to go out and get files that you need. So, so we can talk a little bit about what's next for you using this. So we actually have a 3-step process to get certified with the 3D printer. I've got about 6 people that have gone through that already as kind of my test subjects to figure it out. First step is just download a really simple image and print it. How do I do that? Next one's, okay, let's go out and search that database and find something a little more complex and actually print that one. And then the third step is to actually go build your own STL file from nothing. Start, design it, put it all together, put it into the, what's called the slicer and then print it. So you can go from the very simple, hey, I found this, to the very complex, I want to go all in and design my own. And then, like I said, we'll be working with women's and children's to see what their sonographic devices do to capture the images as well.
Okay.
Yeah, next step, we want to buy the soft material or colored 3D printer, or mostly important, we have to use these 3D printers. So as a faculty, we encourage collaborations. If you want to do anything interested, just let Mark know or let me know. Anyway, so yeah.
The other question we have here, Sophie, is about
Yeah.
colors. Everything they're seeing here so far is one color.
Yes.
We've done multiple color pieces. Our printer is capable of printing up to 4 colors at a time.
Mhm.
The challenge with it is anytime that you do something in color, it takes a lot longer. So Sophie's 36-hour model of the female anatomy, because the support was there, but I'm gonna guess it would be closer to 100 hours for color. Because what it does is every time you change a color, it prints a fraction of a millimeter at a time. So when you get a chance to get up and take a peek, you can see that it's printing a fraction of a millimeter with each layer of plastic. Well, if there's 4 different colors on that fraction of a millimeter layer, it has to stop, suck the old color back up into the reel, spin the new color down in, get it all organized and ready to go, heat it up, melt it, get it to the right spot, print the 3 dots of that color, suck that back up, spin the next. So it's pretty time consuming to do color. So there's that balancing act of, okay, how long do I want to wait? How complex do I want to make this to make a color? Versus can I print something white like Sophie did and then have my students color it? Lots of ways to kind of balance that and see. So what was it an artery you had, the red artery that you put the white dot
Yes.
on?
Yes.
To go in and actually put that white dot would have taken a lot of extra time versus taking a white magic marker and putting the dot where you want it. So it's that balancing act of how accurate does this need to be versus how much time am I willing to spend to do that? And when I say spend, you don't have to sit there for the 36 hours. It does it. That's the good news. The bad news is how fast do you want it? And what it also introduces the chance for it to fail. The more complex it gets, the more likely it is to fail. And this by far is not a science. It's not like our printers over here that work most of the time. I would say we're probably what, about a 50%? I'm probably getting closer to 75%.
Oh, I think you're 75.
Yeah.
Yeah.
But it's still an art. It's not something that you just jump on and hit print and say, okay, we're done. It does take some time, some effort and some thought.
And so, I just wanted to add. This was an example of the top of the heart. I don't know if it's the top, this piece of the heart, took 2.5 hours to print. That was all just one color, green, all the way through with green supports. So it didn't have to change. This, the smaller piece, was a 5-hour print because we did put in the white supports. And it's a smaller piece, but it took 5 hours because it had to constantly change the different filaments. So that kind of gives you an idea of what changing color or filaments would do.
And you did the support in white just so you know what to cut out, or what was?
There's actually a true support material that breaks out and tears out easier than other material. So you can print that white support material and pull it out. The other advantage is you can get white or black or some other color. So you actually know what you're supposed to get rid of too. You're not getting rid of the materials you need or want.
I would worry about that.
Yep. Am I a surgeon? And how skillful am I about being that surgeon to cut those pieces out? Yeah. So what do I want to make sure I leave in?
Yes, and anyway, so I think we have some arts professors here. I would like, at least I use April as an example. April, you teach that stats class, statistics class, right? I think we can put we can print out certain of those like a chart, those columns, and you put on the different of like the puzzles as well. You put on the different of the way, so the students can analyze the mean value or medium value differently. So those, Yeah, those you can change because you can print out one of the green ones, one of the orange ones, then you can change the orders. Let students in classroom analyze it. So that is one of the things I can think. I really don't know Marlene, what do you want to use for your arts class? Yeah, but those ones could use for the arts class too, because they can print out a lot of arts piece. Right, Mark?
Yeah.
Yeah, we print out almost everything.
Well, and we talk about the, the anatomy of the brain and the parts of the brain in the intro psych class.
Mhm.
So, that'd be a great thing for the freshman society.
Yeah, we
Yeah.
printed out a circle of Willis earlier.
Yeah.
Oh,
So,
okay. That was great. I will print out some different lobes on the brain and put together for you if you want to use April.
Yeah,
Yeah.
that'd be cool.
Yes.
I think the big one is, I would go out to somewhere like a Thingiverse, and I've got a list, I'll go ahead and put it into the chat. But there's a place called Thingiverse that has all the models out there, so you can go look and kind of see, and when you start seeing it, your brain really starts to kick into, oh boy, I didn't really think about being able to do that level of work with all of this stuff, because it really is amazing to see how much you can really do with it. I'm working with a company that's doing a women's health and hospital center in Mali, Africa right now. And I work a lot with them, and they've been trying to figure out how to get a reliable water supply. And they said it's the biggest challenge is some of the fittings and things we need for our plumbing. We can't just run down to Lowe's. And so they ship a shipping container about every 6 months for their supplies. And I said, well, why don't you just put a 3D printer and some filament? You can actually 3D print metal as well. Yeah, you can 3D print amazing things. You can 3D print human cells, you can 3D print metal, you can 3D print an awful lot, but yeah, it's getting to be really interesting what you can do. So I said, throw a 3D printer in, throw your filament in, and now you can print whatever it is you need instead of, yeah. So lots of ways to really think about how you can do the different things.
Yeah, I do believe hospital settings, they already use 3D to print it out some of the disposable material. So they one-time use, so they save their revenue for it. Basically, they don't need to buy it, they just print out. But our printers, I think, is at this stage is pretty basic. If you want to print more of the biomaterial, they do require more expensive ones. Yeah.
Any other questions?
Sophie, have you looked at the NIH database of anatomy?
I haven't.
Oh, okay.
Yeah. So those ones we could done something in the future. So any of the idea, we can collaborate with each other, and that would be great. Yeah, and anyway, I'm another planning is publish the papers on these innovative techniques in the health care professional education, such things like this. Yeah.
So Sophie, I'm gonna take the screen over for just a second and we'll show them Thingiverse, and then we'll show them how to actually do some modeling in Shaper.
Okay, great. Thank you.
Great, thank you. All right,
Okay.
so we'll go ahead and share my screen here.
But yet it's.
But they probably can't hear it on the,
It's really
Yeah, they should be able to hear us.
they shouldn't hear the 3D printer.
Okay, yeah, they go, yeah.
from my experience, when Mark has been in here doing things with the 3D printer on, he's sat right where Lori's been and couldn't hear it. The other side.
Can you guys hear it over there?
Yeah.
Yeah.
Oh, yeah.
Oh, yeah, it's definitely here.
White noise.
Yeah, I wanted it in here so you could actually see it, but then by having it in here and working, then I have to put up with the noise, and I know this will be the best way to kind of get it. So here's Thingiverse, and there are lots of these different resources out there. But it's just a library full of different useful and useless items that you can 3D print. So all kinds of different things out there. But I would encourage people just to go out and take a look at what kinds of things are out there. You can do a search.
I'll say that while he's looking stuff up, when I started looking at this with Mark, I just started looking through their more anatomical models, and I found things that I use in my garage that I've 3D printed at home for use with it. So they're like, you may not think that there are things you could use, but just put it in the search and try some different keywords. You'll find there's so many things out there that it's crazy to just.
So they're anatomically correct. So you can actually print all of these different models out. Some of them are a little more interesting than others. But this is simply one site, and there are all kinds of different sites that you can then go out and find the material from. So things that people have put out there, they've just designed it and they're looking for feedback. They let you download it for free and off you go. So you can go that route. You can also go a little more complex route if you want. This is a program. It's $300 a year for people on the regular world, but they offer a very special educator discount, and your educator discount is free. So your students, yourself, anybody can go in and use this, and this is probably one of the most powerful 3D, I shouldn't say most powerful, the most powerful 3D tool a mortal can use. They're the folks that live in the CAD world. That gets pretty complex. This is relatively easy. So I put this together in about an hour and a half. So you can go through and just sculpt and build whatever. So you can imagine for somebody like Melissa, being able to build a tool or a brace or something like that and make it fit to exactly a patient's measurements instead of, okay, well, this is a brace that's closest. We have a size 7, we have a size 7.5. Gee, I'm sorry, you're a 7.25. You're going to have to pick which one best fits for what you're trying to. Now, let's take the measurements and print it for you. So she's actually working on a Shark Tank competition for her students to see who can design the best 3D device. And then they'll get to actually print their device. So lots of fun ways to kind of think about that. Because of the print times, please think about having all of my students in a class print something. As you said, Lori, 36 hours to print half of a female anatomy. Probably don't want one for every student. Probably don't want every student coming in to print something. It's a pretty steep learning curve. It's not simply, unless of course you're just grabbing something to print. If you're going to design something, it's a pretty steep learning curve. But you can do that, and there's some great tutorials out there to help you figure those kinds of things out. But lots of ways that you can start to work and build and do what you want. So to actually process one, let's just go out and build one quick. Get a couple minutes. Create a new file. I'll show you how quick something can start to happen here. We can just hit sketch, and you can change this to whatever angle you want, and you can see the cube up at the top up here. But I want to look from the top right now. So I'm on top of that item, and I'm going to choose a rectangle and just draw that rectangle out. Now this is what that rectangle looks like from the top. I did go the wrong direction, but we'll get there. So here's that item. I can now take that and extrude it. So I can just grab, oops, back to here. Grab that and extrude it. And I can change that to whatever size and dimensions I want in there to start designing.
You might want to mention the maximum dimensions of.
Oh,
that
yes, good
machine.
call. Maximum dimensions. You can design any size you want. Printing it might be a little more of a challenge. You can go up to 10 inches by 10 inches by 10 inches. You can stretch that a little bit. I did, this is probably pushing my 10 inches to the ultimate. But
What is
I'll show you in just a second. Good question. Perfect question. It was one of those things where, like I said, you start to think about how can I solve this problem? What can I do with this? So this was my first prototype, but you'll see it in a second. But this is actually starting to push about 11 inches. And I put it diagonally across the plate so that it would print. But what I was actually trying to run into is, it's called printer poop. Okay, and if you change colors a lot, it dumps printer poop out of the back. So here's our printer poop so far.
Oh. Oh.
And I got tired of coming in and cleaning the floor after 36 hours of cleaning. So as they generated the printer poop,
That's delightful.
I just thought, well, let's just take this and design it right around. So you're good.
Oh, wow.
And then so it just drops the printer poop into the garbage for me. And then there's recycling programs for printer poop. So, yeah.
That's good.
So that was the problem. But I had, if you look at this, there were screws and all kinds of things that I could tap into over here to hold it. But I didn't want it to get in the way of and cause jams. There were screws over on this side that were in the way. So I just went and redesigned everything on this program and said, all right, we're close. Printed it and it didn't quite fit the way I wanted. So that was Rev 1 and printed another Rev, and now that Rev 2 is on the device. But all kinds of things that you can think about that it's just like, okay, I need this. Okay. What do I need? How do I want to design it? And what do I do? So lots of ways that you can go about designing all kinds of different tools for what's there. So first step, one, it's open for anybody that wants to get certified on using the 3D printer now. We've got a printable 3D or 3-step process for you to go through. Sit down with you and we can work through it and get you going. And then I typically end up helping folks anyway. So got projects and ideas and you want to try it, let me know. But I would encourage you to go out to Thingiverse, or I'll send a list of several others that are out there that you can start to dig and look. But really what you're looking for, if you just do a search on, my first word is free STL files, you'll come up with a list of stuff you wouldn't believe on the things you can find. Right, so Sam, Tommy, Linda, STL. That's what you're looking for.
St. Louis.
St. Louis.
St. Louis, there you go. St. Louis files. Any other questions for Sophie or myself? Well, I'll go ahead and turn this around, and as you're coming through, if you want to actually see what it's doing to print, you then have access. And we've got a knee starting to take shape in there pretty well, so. But lots of surgeons, like you were asking why, we've already got 3D models, lots of surgeons actually printing out your body part. This is what's happening in your body right now, so you can see it. And off they go.
How hard will it be to get that softer material Sophie's talking about? Is it just like expensive?
The softer material Sophie's talking about is right here.
Like it's just made from a different, just different kind of.
There's 3 or 4 different, well, lots of different kinds of filament based on what it is you're looking for. So here, this black material is really built for materials that are outside that are going to be exposed to the sun. So that this is, I'm trying to remember what's it called. TPU, the TPG? ABS plastic. And an awful lot of what is built out there is ABS plastic. This is ABS plastic. It's going to hold up to sunlight and ultraviolet light and all that fun stuff that's going to break it down faster. If I leave this outside in a couple months, if not a couple weeks, it's probably toast. This is really built for that kind of world. This is, I think, TPU. Yeah, TPU. This is a softer, more flexible. But you've got to be really careful with this one. It dries out or sucks up moisture. So you've got to be really careful with it. So we bought a vacuum pack to vacuum pack it back so that it would stay relevant. A typical reel is about $16 for the reel. This was, let's say it's 16, if you buy it in bulk, somewhere between $16 and $35, depending on how much you buy. This was about probably 40 or 50 for this reel. So it's not terribly bad. It's just a matter of keeping things available and on stock, and what do people want to try?
So you can buy, like Amazon, when I buy it for sign, we buy it for $23. And we've had it over a year, and I probably print things weekly with it, 3-4 times a week, and we haven't had to purchase any more yet. So you make a lot with it. It goes a
Lasts a
long
long
way.
time.
Yeah.
Yeah, it all depends on what size Sophie did a pretty good number on our stuff with the 72 hours of printing the female anatomy, but I think it was well worth it. Just the learning process of what it takes to do it was great. But you can burn through it pretty quick if you're doing larger projects like
Do
that.
you want to start with them?
Whatever's
Would
easier
that
for
be
you.
easier for you?
Yeah, I don't think I have any other.
What was that
meetings.
question?
Just listening
They're
to
they're
it.
talking on there.
Okay,
Sorry, for my calendar. You think I'd remember? I do have a 2 o'clock meeting, so probably good to start with.
So
you
is
guys.
there a light in
Yeah,
there
I
so that
appreciate
maybe I
it.
see better or
Yeah.
just, oh, there is?
So I have like sandpaper holders that I put into a pegboard.
Okay.
Like I have some of those. I built like just small containers that I put things in. So I don't know for like sim lab, if you need to put like all the needles somewhere, you need just like a little tray. Like I print those a lot. So that's what I've done. Also just toys for my kids. We do that mostly. But like honestly, during this hour, I was like halfway listening, halfway going through, and I came up with probably 10 things that I want to print. Like we have brains. This is a gestational brain, so it has different gestational ages, and all of these models are free. So like that's how quickly you can find this if you search it.
I kind of want a regular heart, a congestive heart. Left side, right side.
Yeah, like I haven't looked for those specifically, but I imagine doing just a quick Google.
I don't know how small it can go, but just like for diabetes. Just how small those vessels get. And why you have neuropathy.
I think that one, I could pull some data from the analogy table. Analogy table have over 200 different of the 3D imagings are already. So the data on it, if you want to print out the congested heart, so we could basically basically how dilated, how thick the wall is on the left
Right.
ventricle wall. We can have a specific size on it. Yes. So
Yeah,
I
I'm
think
just thinking maybe that'll help them. Visualize a different
Yes.
way than just left-sided involves the lungs and right side involves return of blood, but it's like, this is why. You
yes,
know,
that is great. Actually, I want to print out all those coronary circulations on those congested heart as well, because they can compress on those blood vessels when they are doing the systole. So anyway, so I would like to try that soft material first if it works, so we can print out some squishy ones. So make sure they have systole diastole moment on it.
lots of different 3D models out there for congestive hearts. There's diabetic foot. So I just did a quick search on diabetic congestive heart STL file.
Sophie, I know you were looking for COVID-19 models to 3D print. The NIH has those there for you for free with the different proteins and whatnot.
That's on the NIH website. I see a couple of like heart ones that are slices.
Yeah.
They're not for congestive heart failure.
Right.
But
Well, just, the diabetic foot. I don't want to gross anybody out. There was a patient, yeah, it is what it is. There was a patient yesterday and, diabetics usually are, I would say usually are, I just know my own husband, denial. But there was a patient with a diabetic foot ulcer and his comment was, I didn't think it was that bad. It tunneled from one ulcer to the other ulcer.
Wow.
Yeah, this is well, just to be, just thinking of the different stages of just pressure ulcers what they see, unless they actually get to see a dressing change in the process, the undermining and the tunneling of the different, they're going, what does undermining mean? And you're using your hand and trying to go, well, this is undermining. And they're going, huh? And this is tunneling, it goes through. And they're going, I don't get it, but I'm just curious. It's just another visual because
Yeah.
they're used to just the 2D picture.
Yeah.
And it's like,
Well, we've
And
all
the
seen what the ideal version of everything looks like.
Well,
What
yeah,
we haven't
right.
seen is what you're describing when
Yeah.
things go wrong. That's
Yeah.
what
Things
people
go
need to
wrong.
understand.
I think it'd be very interesting to use this for patient education for the visually impaired.
oh, yes.
Absolutely, so that they can actually feel what
Feel
it
it.
looks like. So here's the NIH, it's 3d.nih.gov. And you can go out and do searches on virtually anything there and download any of the 3D files you want.
Fractures.
I'm sorry, what's that?
We're talking about there down below where it's talking about fractures.
so there's a good one that has a fracture acromion process
Nice.
that I'm gonna talk to Mark about later.
Yeah.
He doesn't know yet. This hour when I was looking.
But I'm more than happy to help people learn how to become certified on this. I do want you to get certified through at least the first two. To be ready. And then once you do that with me, I'm glad to sit down with you at any time and help you through the rest of it. Because it, like I said, it's not a sit down and do this kind of thing. I'd say I probably have between 200 and 300 hours on this now. And I'm finally starting to feel like after 200 or 300 hours that I can start to understand what it's doing. Yeah, so it's not something that you just jump in and hit print and you're done.
Oh, and especially the creating your own models.
Yeah.
I mean, that's a whole nother level of spatial awareness that, yeah, it starts to get kind of crazy.
So you make one and it doesn't work. Can you recycle it?
Just throw it in the bucket and start again.
That sounds very depressing, but it's not really as bad as it sounds like that. Yeah, it's unfortunate, but you put it in, you come check on it every couple of hours and that's like, I don't check on my things overnight when I leave them going.
Yeah.
You generally, they just go.
What if it's not working? Can you stop it?
Yeah, you can stop in the middle.
So.
So
Well, you know, figure out what went wrong, but why did it not
So
work?
don't start over. You can't like stop it midway through and make a correction.
Oh, yeah.
I mean, can you
No,
can't.
you can't do things like that. Not that I know.
Otherwise, it would do me no good to check on it because.
Well, then you know you're not gonna waste all that extra killing.
So one of the things, I'll just bring this over. So I said it does the time-lapse photography. This is actually wireless and you can hook in here in the college and you can actually watch it print. From, yeah, it's about as exciting as paint dries.
Right.
It's also about as addictive as crack. Because you start coming in and you sit and you watch it, and it's like, and 10 minutes later you're going,
Can you stop? Can you stop it?
Yeah, you can stop it remotely, you can, yeah,
So if you're at home and it's not doing what you want it to do, you can
you can
stop
stop
it.
it. Now, because of the hospital security, I'm not always easily able to get in from home. But I do get messages when something's gone wrong. It says it's gone wrong and I can stop it and come back in and say, okay, now what happened? And the whole reason for the shoot was exactly that. I print these long prints. And they had a bag back here to collect it, and the bag would fill up. And then it would back up into the printer and cause a clog and a lot of just stupid little things that can happen. So you learn a little bit along the way, and that was the whole reason for doing the print or the shoot was, all right, well, you gotta fix that.
You should sell it to the printing company.
Yeah. They've
The printer.
got so many models of so many things that people have done for different stuff that, yeah. All right, well, we're right at 12:30. We appreciate the time. If anybody wants to stick around, I'll go ahead and open this up for a second or two.
Thanks, Sophie.
Thank you, Sophie.
Thanks,
Have a good
Sophie.
day. Thank you. You can actually see what it's doing, but it's just printing layer by layer.
The beginning of Incredible 3. Yeah,
Wow.
and the cartoons, there's a character, a bad guy called the Underman.
Okay.
And his
Like-
character is evolved. Yes.
That's kind of why I put it here.
Oh, I
You get the
get that.
band up above.
Connect them to that,
Together.
to show them, okay, so
Yeah.
this is, exactly.
Yeah.
And it's like maybe a 3-minute clip, but.
So that would be
But it would
fun.
help,
Get
yeah,
their attention.
exactly, yeah.
So it was just interesting.
Yeah.
I didn't go in. I had the flu spray. You kind of combat the odor.
Oh, for sure.
What is it really happening?
So you're, is that something that you could?
Yeah, but to actually see it and
The way
understand what,
the one student was describing, and there were three different ulcers.
yeah, my son
The way
did
she
heart
was
surgery and they actually did his heart and modeled it.
Area.
Just showed it.
You can
Yeah,
feel the bone, but you can't quite see the bone.
Mm.
And it's
yeah,
like,
his was
oh,
pretty significant,
wondering.
so they took the time to really
I know
study
how
it,
stubborn my husband was when he had
know what they're
this,
doing.
and he still is a little stubborn.
Sure.
Just because he had a partial education and I don't like the way the skin overhangs. And it's like, sad Lucy.
They didn't make.
No.
It's so, pretty sure. I
They are-
think it's Sonia.
No, it's like, let me
That's
see your
called,
butt.
I just got out of the shower.
Yeah,
And so
yeah.
that's a standard
And that's
piece
how
that
he was
they do.
when he lost.
And how you tell how fast your printer is,
But
Oh, sure.
yeah, this.
is they say this is how fast.
Yeah,
your printer
with this period.